All right, welcome back here on Math with Zord. We are starting into section 4 on inequalities, talking about absolute value equations. The next 3 sections here in chapter 5 are all about absolute value. We're going to start with equations, then look at less than and greater than inequalities. So first, we need to remember what absolute value is. An absolute value is the distance that a number is from 0. Okay? Since it's a distance can never be negative. Absolute value is always positive. So the easier way to remember absolute value is to remember that it always makes a number positive. Okay? So if we take a look at this first example where we have the absolute value of x is equal to 5. Let's take a look at a number line and see what we can find out about what numbers we can plug in for x to make this true. Okay, so we take a look here. We need to find a number for x that will make the absolute value of x equal to 5. Well, we know that the absolute value is the distance from 0, so we know that the distance from 0 to 5 is 5. And we know that the distance from 0 to negative 5 is 5. Therefore, we can say that in order to make the equation true, x is equal to 5 or x is equal to negative 5. Okay, the easier way to write that is x equals plus or minus 5, where you just put both signs in front of the 5. Okay? But either way, we know that x is equal to 2 different numbers. 5 and negative 5 make this true. Okay? That means we have 2 separate cases that we have to look at every time we have an absolute value equation. We have to look at case 1, where the value inside the absolute value is positive. That's what we looked at when we said x was equal to 5. The other case is when the inside of the absolute value is negative. That's what we looked at when we said x was equal to negative 5. Okay, so let's look at this first example. The absolute value of x minus 4 is equal to 3. According to the 2 cases we just talked about, x minus 4 can either be equal to positive 3 or negative 3. Okay? So what we need to do is we need to solve x minus 4 with it equal to both positive 3 and negative 3. So let's first take x minus 4, set it equal to positive 3. Very simple equation. You learned how to do this in 6th, maybe even 5th grade. Add 4, that means x can equal 7. But we also need to say that x minus 4 is equal to negative 3. Again, simple equation. We add 4 to both sides, so this time x is equal to 1. Okay? So we have 2 different answers. X is equal to 7 and x is equal to 1. Now what we do need to do is we need to always plug them back in. Sometimes they don't work. There's special cases. We're not going to go into it this year, but you'll see in the future, 8th grade, 9th grade, 10th grade, where these answers will not work. So you have to get in the habit of plugging them in to check. So we check the absolute value. We're going to plug 7 in first. 7 minus 4 equals 3. So 7 minus 4 is 3. The absolute value of 3 is 3, which checks out. And we also need to check with 1. The absolute value of 1 minus 4 is equal to 3. 1 minus 4 is negative 3. The absolute value of negative 3 is positive 3. So that also checks out. Okay? That means our 2 answers are x equals 7 and x equals 1. Okay? If that made sense, I'd like you to go ahead and pause the lecture right now and try this next one on your own. 2x, the absolute value of 2x minus 3 is equal to 17. What you're going to want to do is Let's take the 2x minus 3, set it equal to positive 17. 2x minus 3, set it equal to negative 17, and then solve. All right, so go ahead and pause it right now, see if you can do this on your own. Then when you replay it, I'll walk you through this. All right, so what we're going to do here is, like I said, 2x minus 3, just like up top, equal to 17. We'll also take 2x minus 3 and set it equal to negative 17. So we'll solve this positive one first by adding 3. That cancels. 2x equals 20. Divide by 2, and x is equal to 10. Now let's solve it when it's equal to negative 17. We can add 3. 2x equals negative 14 this time. Divide by 2 so that x equals negative 7. Okay. Now the last thing we have to do is plug both of them in just to check. So we can start 2 times 10 minus 3 is equal to 17. 2 times 10 is 20. 20 minus 3 is 17. The absolute value of 17 is 17. Then we need to check negative 7. So 2 times negative 7 minus 3 is equal to, sorry, there's static coming off the speakers right now. Hang on. All right, hopefully that worked. 2 times negative 7 minus 3 has to equal 17. 2 times negative 7 is negative 14. Negative 14 minus 3 is negative 17. The absolute value of negative 17 is 17. Therefore, our two answers are x equals 10 and x equals negative 7. All right, hopefully you tried that on your own and you got it correct. That's the goal here. Flip over to the back. Okay, now we're going to try something a little bit different with this. Okay, this time I want you to use the number line to make your own equation. Right, and hold on 1 second here. All right, I'm back. Sorry about that. I had to run and find my book real quick so we could put this number line up here. So we're going to start with this number line. This is going to be given to you. We're going to start counting at 3, 4, 5, 6, 7, 8, 9, and we're going to go up to 10. Okay. And we're going to also be given a point at 3 and a point at 9. So I guess we really didn't need to go to 10. But this is what you're going to be given, is this number line with 2 different points on it. You're going to need to write the absolute value equation that this number line comes from. Okay? So we first have to find the midpoint of the 2 given points. You start at 3 and 9, and you cover up each side. You can come in 1, come in 1, come in another, come in another, come in another, come in another. You can see they meet at 6. So our midpoint is 6. Okay? The midpoint is used to make the part of the equation inside the absolute value signs. Okay? And notice I have an asterisk here. When writing the absolute value equation, always use the opposite. Our midpoint is a positive 6. When we write it in the absolute value, it becomes minus 6. Okay? If that had been a minus 6 for the midpoint, inside the absolute value would be a plus 6. Okay? So we find that the part that it equals. We already have the absolute value of x minus 6. Now we need to find what it equals. So we need to see how far apart each point is from 6. Okay? And each point, we already said by putting in the green marks there, each point is 3 units from 6. Okay? Therefore, that means the equation that we have is the absolute value of x minus 6 is equal to 3. Okay? Hope that made sense. Now you're going to try one on your own. Whoa, there we are. Try one on your own here. Okay. Let me give you this number line. All right, we'll start counting at -4, and we're going to go up to 6. So -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. All right, and that's where the 2 points are going to go. So if you would, please pause the video now before we start solving this on the video so that you can try to work it out yourself and then double check it after we work it out on the video, just like the front side. All right, so pause it now, please, right now. Thank you. All right, so first thing we're going to do is find the midpoint. We're going to start counting in. Okay, and if we start counting in, we find that the midpoint of this is at 1. Going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our midpoint is right here at 1. That means the start of our equation is x minus 1. Now, as we said, the way that we find the part that it's equal to is we take a look at how many units each is from the midpoint. We said this was 5 units. This was 5 units. So we know that absolute value of x minus 1 is equal to 5. All right. Hope that made sense to you. Hope you enjoyed the lesson. We'll see you in class whenever we get this done, get some practice with it. And we'll be back with solving absolute values, either less than or greater than. I'm not sure what the next section is. It's one of those two. So we'll see you in a little bit. Bye.